Alright, so for section 4.5, we want to talk about graphs of sine functions and cosine functions, and kind of answer questions based on that. What's the amplitude? What's the period? Does it have any kind of shift? And I'll talk about what those mean. Alright, so let's just look at the sine function first. And so let's just look at the graph. So we'll just look at a basic sine graph. Alright, and you've looked at this before, but just to show you again. Alright, so sine always starts at 0, 0, or the basic sine does. Alright, and then we have, we'll say pi over 2, pi, 3 pi over 2, and 2 pi. And of course, obviously, this is not drawn to scale, but that's okay. Alright, and so the sine function does something like this. Okay. So that's the basic sine function. All right. All right, and so the sine function has a period of 2 pi. Okay. So the period is 2 pi because the period represents the distance or how long it took to make one complete cycle. Okay, so we go up, then we go down, and then we're back to 0. Okay, so the valley and then the valley and peak, right? That it took 2 pi, distance of 2 pi, for that to make that one cycle. Okay. Also, the height of these waves is called the amplitude. Okay. So the height of the wave from 0 is the amplitude. Here we have an amplitude of 1. Okay. On a similar token, we have the cosine function. Okay, so we're going to look at the graph of cosine. All right. Cosine and sine are similar, except cosine starts at 1. So we have pi over 2, pi, 3 pi over 2, and 2 pi. Okay. And so the cosine function starts at 1, and it goes here, then it goes down, then it goes up, and then it goes up to here. Okay. All right. The period of it is still 2 pi. So we go from here to here. So the period is still 2 pi because it took, in the time that it took to go down, have a valley, and back up to a level, was 2 pi. The height of the wave is 1. So we have an amplitude of 1. Okay. So these are our basic sine and cosine functions and graphs. Then we can do things to alter them. Okay. All right. So now let's look at the generic sine function. So sine, or excuse me, let me rewrite this. Let's say this: y is equal to d plus a sine of bx minus c. The same is said for cosine, so it's written the same way. D plus a cosine of bx minus c. All right, so let's talk about what these values mean. Let's start with a. A, or the absolute value of a, technically, is the amplitude. Okay, a represents the amplitude. Since our period, as we showed in the two drawings, is 2 pi, all right, then this b nonsense is going to have to do with the period. So it's going to affect the length of the period by either shortening it or extending it. So the period is always just 2 pi over b. Okay. C is a horizontal shift or translation. Okay. D is a vertical shift or translation. Okay. So those are all of our components of the generic sine and cosine functions. Okay. So now let's look at 2 example problems here and answer some questions about it. All right. So let's look at example 1. We'll say y is equal to 4 times the sine of 9x. Okay. Well, the amplitude, we know according to that generic form, is a, which is whatever's being multiplied by the sine function. So we have an amplitude of 4, right? If it were -4, it would still be, the amplitude would still be 4 because it's the absolute value. And sine has a period of 2 pi, but we have this 9x, right? Well, 9 is equal to b here. The period is 2 pi over b, so it is 2 pi over 9. Okay. That can be derived if you need this by just setting 9x equal to 2 pi and then just solving for x, right? That's how that was derived. But if you just know that it's 2 pi over b, then you're fine. Okay. All right, and so now let's look at a shift. So let's say example 2. Let's say that y is equal to 4 plus 3 cosine of x plus 6 pi. Okay. All right, so the vertical shift of this, right? Just like if we were just a line of a graph of a line, if we added 4 to it, we would just move it up 4. So it has a vertical shift of 4. Okay. The horizontal shift, however, we have to think about for a moment. Okay. So the horizontal shift, looking at the generic form, we have minus c. Well, minus c actually moves us to the right because c would be positive. So in the generic form, it's minus a positive c. All right. Well, here I have a plus. If I see this plus, that means that it has a shift to the left. Okay, so it is a horizontal shift of, we'll say 6 pi to the left. Okay, so if it's positive, then that means that we shift to the left. If it were to be negative, we would shift to the right. All right, this concludes section 4.5. If you do have any questions, please feel free to email me, and have a great rest of your day.